Hi student, this is Sokumar. 12th Standard Business Mathematics and Statistics, Chapter number 8, Exercise 8.2. Here we are going to discuss about the null hypothesis and alternate hypothesis. Okay, here there are two types of statistical hypothesis. They are null hypothesis and alternate hypothesis. Now, the null hypothesis that is represented by the letter H0 is set as follows: H0 that implies mu that is equal to mu naught. H0 such that mu that is equal to mu naught. Mu refers mean. The next one, alternate hypothesis. Any hypothesis which is complementary to the null hypothesis, contrary to the null hypothesis, is called as the alternate hypothesis and is usually denoted by H1. For example, if we want to test the null hypothesis that the population has specified mean mu that is H0 such that mu that is equal to mu naught, this is for null hypothesis. Then the alternate hypothesis could be any one among the following. It depends upon the problem. H1 can be considered as mu that is not equal to mu naught if you are given neither increasing nor decreasing. No such word is in that question. So you have to consider mu is not equal to mu naught. And H1 such that mu that is greater than mu naught when if you are given increasing, more than, greater than, such word is given, you have to consider mu is greater than mu naught. And third one, H1 can be considered as mu less than mu naught if you are given decreasing or less than. Okay. Next note, under the null hypothesis that the sample has been drawn from a population with mean and variance sigma squared, there is no significant difference between the sample mean x bar and the population mean mu. The test statistic for large samples formula is that is equal to x bar minus mu divided by sigma by root n. Okay, while working on the problem you can understand the concept very well. Now another note, if modulus of z which is less than z alpha, the null hypothesis is accepted. If modulus of z which is greater than z alpha, the null hypothesis is rejected. You have to note down everything. Apart from that, a normal probability table you are given. It will be useful for working on the problem. We have critical values for z alpha: two-tailed test, right-tailed test and left-tailed test. For this in particular, if mu is not equal to mu naught, you have to apply two-tailed test. Two-tailed test for that first subdivision. For second subdivision, mu is greater than mu naught, we have to apply right-tailed test. And for the third one, mu is less than mu naught, that is for left-tailed test. Okay. First subdivision for two-tailed test, second one for right-tailed test and third one for a left-tailed test. So look at the diagram for two-tailed. It can be considered as z alpha by 2. This portion can be considered as minus z alpha by 2. This is the diagram for right-tailed test. This diagram for left-tailed test. Okay, left-tailed, right-tailed and two-tailed test. Now exercise 8.2, problem number 14. A sample of 100 items draw from an universe with the mean value 4 and standard deviation is 3 has a mean value. You are given 63.5, that is wrong. Please change it to 3.5, not 63.5, 3.5. Right here 3.5 only. Okay. The question is the difference in the mean significant at 0.05 level of significance? The question is, you are asked to test the significant difference between sample mean and population mean. Again I tell you, you are asked to test the significant difference between sample mean and population mean. For the given condition, you are asked to test whether the significant difference between mean, sample mean and population mean, so that you can go for hypothesis testing. This can be done only by hypothesis testing. So now what's the data given? We can write first. Look at that. Sample of 100 items, that's a sample size, has a mean of 3.5. That's a sample mean. Sample size, sample mean. In between what is given? Universe with mean value. Universe, that means population mean is 4 and population standard deviation is 3. Again I tell you, this is a sample mean. This one is, this is a sample size that can be represented as n. This is a sample mean. And universe means population. Population mean is 4 and population standard deviation is 3. Okay. Given sample size that is represented by the letter n, that is equal to 100. Sample mean that is represented by x bar, that is equal to 3.5, not 63.5, 3.5. After that you are given population mean and population standard deviation. Population mean that is represented by mu. You are given that universe in that question, no, that should be considered as population. Mu that is equal to 4 given, and population standard deviation, and its standard deviation, population standard deviation, that is represented by the letter sigma, that is equal to 3. Okay. We have to decide whether the given condition is accepted or rejected. For that only we can go for the hypothesis testing. I already told you two different types of hypothesis. One is a null hypothesis, another one is alternate hypothesis. For null hypothesis, what it means? We are fixing the given condition is correct. What's the condition? No significant difference between population mean and sample mean. There is no significant difference between population mean and sample mean. What the data given is correct only. You are accepting. That is called null hypothesis. Again I tell you, we are fixing the given condition is correct. What it means? The given data is correct. That there is no significant difference between population mean and sample mean. Everything what is given, everything is correct. That is the meaning of null hypothesis. I start with the null hypothesis. Start with null hypothesis. That is represented by H naught. Such that you have to consider mu that is equal to mu naught. Generally H naught, that is mu equals mu naught. Mu naught, that is, this is a mu naught. It should be considered as mu naught. Mu and mu naught are same, that is equal to 4. This is for null hypothesis. So there is no significant difference between sample mean and population mean. I write here, there is no significant difference between sample mean and population mean. We are fixing. That means we are fixing the given condition is correct. Null hypothesis. After that, alternate hypothesis. Alternative hypothesis. That can be represented by letter H1. We have to be very careful over that alternate hypothesis. Okay. Now, already I have given that explanation for that alternative hypothesis. Look at that. H1, that is the alternative hypothesis. If mu is not equal to mu naught, that means if you are not given about that increasing or decreasing in that question, you can make use of that condition. That is called a two-tailed test. For increasing, mu is greater than mu naught. For decreasing, mu is less than mu naught. Now we can refer the question. In this question number 14, there is no word increasing or decreasing. That means you are given that two-tailed test. Neither increasing nor decreasing. What it means? Two-tailed test. So in that case, you have to consider mu is not equal to mu naught. Mu is not equal to 4 because H1 such that mu is not equal to mu naught that is equal to 4, for not equal to 4. For your reference, I write here, so two-tailed test. Since two-tailed test. Okay. Alternative hypothesis is complement of null hypothesis. So that what we have mentioned here, there is no significant difference. Here we have to mention there is a significant difference. There is a significant difference between sample mean and population mean. Okay, alternative hypothesis is contrary to null hypothesis. Now two stages over. Now we can go for the third stage, that is level of significance. Level of significance. That is represented by the letter alpha. Given alpha that is equal to, look at the question, 0.05 level of significance. 0.05. You can write that 0.05 in percentage. For that you can write 0.05, that means 5 divided by 100. You know that 5 by 100 means 5% level of significance. Now you can refer the table. We'll look at that. Level of significance, here it is, the percentage is 5%. It is a two-tailed test, correct? For two-tailed test, 5%, modulus of Z alpha that is equal to 1.96. Have tried? Modulus of Z alpha that is equal to 1.96. From table, modulus of Z alpha, or else you can write Z alpha by 2. The Z alpha by 2 means it's a two-tailed test. That is equal to 1.96. Okay. For your reference, I write here two-tailed. So 3 stages over. Now we can go for that Fourth stage, test statistic. Test statistic, that is a heading. For that you have to make use of this formula Z, that is equal to x bar minus mu divided by sigma divided by root n. X bar minus mu divided by sigma by root n equals, we know the value of x bar. X bar here it is a 3.5. okay, x bar that is equal to 3.5 minus mu that is equal to 4 divided by sigma that is equal to 3 by root n value is 100. That is equal to 3.5 minus 4, that is equal to minus 0.5 divided by 3. You know that square root of 100 is 10. That is equal to minus 0.5 into, division become multiplication, 3 by 10 reciprocal is 10 divided by 3. That is equal to minus 0.5 into 10, that is equal to 5 divided by 3, that is equal to minus, if we divide you will be getting 1.6666. it is going on 1.666, it is going on. We can write minus 1.667. Since the fourth digit is 5 or more than 5, 1 can be added with the previous digit. Since it is 6, so 6 becomes 7. That's approximate value. Then you have to find out the modulus of Z value. Modulus of Z, that means modulus of, this is Z value, modulus of minus 1.667. Modulus, it is an absolute value, it cannot be negative. So minus become plus only 1.667. okay, 1.667, since 1.667, here significant level value, here it is, what's the value? 1.96, 1.96, which is less than 1.96. actually this is mod Z value, correct, mod Z, which is less than 1.96, that is Z alpha by 2, or you can write mod Z alpha. So I write Z alpha by 2 because it's a two-tailed test, so you can write Z alpha by 2. For two-tailed test only we are using Z alpha by 2 or else modulus of Z alpha. Otherwise, whether it is a left-tailed test or right-tailed test, you are using only Z alpha. Remember, here it is. You can refer the table. Look at that. Z alpha for right-tailed test and left-tailed test. So modulus only for the two-tailed test. Remember. Again, look at that. Here, modulus of Z is less than Z alpha or Z alpha by 2. The null hypothesis is accepted. If it is greater than, null hypothesis is rejected. Here, accepted. Since it is less than, you can write the null hypothesis that is H naught is accepted. That means that therefore the given statement is absolutely true. Finally, you have to write that result, that is called inference. So what I have mentioned in that null hypothesis, there is no significant difference between sample mean and population mean. Finally write the result, because we are accepting that null hypothesis. There is no significant difference between sample mean and population mean at 5% level of significance. Over. Problem number 14 is completed. Then I'll be teaching problem number 15 in the next video. Thank you, children.